Okay guys, we are starting a new unit today. We will be talking about probability. Last unit was statistics. Today specifically we'll be covering some vocabulary, populations and samples, what that means, and how to take a sample of a population, okay? So a population is the entire group of something, like think the population of the United States, or the population of Tennessee, or the population of India, okay? A sample is part of that population, okay? So when you take a sample, you are taking part of the population, okay? And the reason is you take a random sample to find so you don't have to ask every person or count everything in a population. You take a sample randomly to figure out something about that population, okay? Like for instance, I would be like, I could choose, I don't know, in the state of Tennessee, if I wanted to find out how many people had brown hair, I could take a random sample from every county like 10 people from every county and figure out what that is. And it would apply to the whole, probably more like 100 people per county. It would apply to the whole state. So basically, there's 3 criteria about samples that make sure that they are unbiased and fair. You want your sample to be fair. And you all know what bias means, okay? So in order to be fair, the samples must be selected randomly, okay? They must be representative of the population, and they must be large enough to provide accurate data, okay? So randomly would be like you choose every 10th person that's walking into a football game to see if they are going to buy a hot dog, something like that, okay? So give an example here, and we're going to go over the different ways to sample and talk about why they either work or don't work, okay? So the example is you want to estimate the number of high school students who ride the bus, okay? And we're going to be considering the criteria that I've given for what samples must have, okay? 4 students in the hallway. Is that going to be a random sample? No, it's not, okay? Because it's not large enough to provide accurate data. It doesn't follow the last criteria, okay? I'll write this on the board. It's the 3rd criteria, not large enough, okay? Okay, now, another one would be all band students. Well, that probably won't work because all band students is a specific, like, not demographic of the high school, but it's a specific criteria. It's not representative of the entire population. So that would be the first criteria. It doesn't represent the entire, so no rep. I'll put no rep. Okay. And then the part C, it says 50 random seniors, and that one you may have to think about. 50 seems like a decent sized number, but let's think about seniors. Well, we're trying to figure out if they ride the bus or not. Well, what do we know about seniors? Well, all of them are at least old enough to drive, and if you look at most high schools, a lot of them typically do drive. They have their own cars. It would be the same thing as saying, well, determining the number of high school students who ride the bus based on just freshmen. Well, no freshmen, at least most freshmen, are not old enough to drive yet, so that affects that. There will be more. So you would have to choose from all of the classes, seniors, juniors, sophomore, and freshmen. So that would be, again, not representative of the entire population, and probably also not selected randomly either, okay? So no rep. Now let's look at the last option. It says 100 students randomly during lunch. That actually meets all the criteria. 100 is a good number because typically high schools, they vary in size, but so usually they're in between like 1,000 some odd students, I think 1,000, 1,200, 1,500. So 100 students is a good size sample. They're picked randomly during lunch, and so that means that no one with a particular characteristic is being chosen. They'd be chosen evenly from each class. So that would be the one that is the best way to sample this, okay? So I'm gonna put a big check there because it's large enough to provide accurate data. It's representative of the population. All of the classes are represented. And it says, again, it's selected randomly. It says selected at random, okay? Now, there's different ways of selecting random things. Like, for instance, when we did the white elephant at Christmas time, right before winter break, and you all had numbers. Well, that was a random way of determining the order because Miss Emma put all of the numbers in a hat. We all drew one out to determine which order we went in. That's a random way of collecting data, or sort of collecting data, I guess. It's a random way of doing that. Okay, instead of just determining like going what order that people sat in, that's a random way of doing that. Another example I can think of would be this. Say I wanted to figure out what how many red Skittles are in a massive 5-pound bag. It's like 1,000 Skittles or something. Well, the way I would do that is, let me actually write this down. Again, what you do is you look at your criteria. Let me write problem down. Yes, I'm using my hand to erase this. I don't know what I did with my paper towel. Okay, so determine how many red Skittles in 1,000 Skittles. Okay, well, what I would need to do is I would need to choose a random sample, okay? What I would suggest doing is, since it's 1,000, I would choose probably 100 of them and then count the number of red, and that would be representative of the population. So there's 1,000. 100 is a tenth of that. So, and then another way you could do that is you could put them all in a big bag where you can't see the colors and then just draw them out basically until you get to 100 and determine how many red Skittles. So put in bag, draw out 100, count number of reds. Okay, and that would be, you multiply that by 10 because 100 is 1/10 of 1,000, so I'll count the number of reds in that 100, multiply it by 10, and then that would tell me about how many most likely would be in that bag of 1,000. Okay? There's other things you can do too. When you're, for instance, you have a 6-sided die and you want to find the probability of rolling an odd number. Okay? You would just, generating a random sample then is you just rolling the die like normal. Okay? Let's see here. So your work today is just going to be doing this, looking at different scenarios and telling how to take a random sample, or telling if a sample that was taken was biased or fair. Okay? That's it for today.